Today we are going to see an interesting and important topic, that is crystal field splitting in octahedral and tetrahedral complexes, and easily to identify low spin and high spin from weak field or strong field ligands through spectrochemical series. Yes, chemically, spectrochemical series has proved that weak field ligand and strong field ligand, and they have given an increasing order. Generally, you know very well crystal field theory. Ligands are approaching to the free metal ion. The splitting point has taken place. The splitting point from the d orbital, it has taken from dxy, dyz, dzx as lower energy, and what dx square minus y square, that is higher energy. Lower energy we can say T2g, and higher energy we can say EG. And you have known the value also. Last video we have gone through that only. So through that we can identify very easily, along with that weak field or strong field. Through that we can identify whether it is a low spin or high spin from the point of spectrochemical series of weak field and strong field ligand. Okay, now as we have gone through VBT theory, crystal field theory also related to that point, but in a different way it has mentioned. Okay, today we are going to see these are the points and the comparison between the compounds, which is a weak field, which is a strong field, to whom it has joined with that metal ion, we can mention it's a weak field, and all those important questions from the board level. Today we are going to see these are the main points. Yes, come on, let us go for that. Now, in the crystal field splitting, octahedral complexes, tetrahedral complexes, comparatively tetrahedral complexes are smaller than the octahedral complexes. Why? Because here 4 ligands are there, here 6 ligands are there. So depends upon the ligands, the splitting will be taking place. Yes, one more thing also, nature of the ligands also. What is the nature here? Weak field or strong field ligand. Yes, and one more point, none of the orbitals splitting directly towards the ligand, hence splitting will be very less in the tetrahedral. Okay, now the nature of the ligand we can identify very easily whether it is a low spin complexes or high spin complexes through electronic configuration. So generally electrons are filling in their orbitals d1 to d3, that means dxy, dyz, dzx. It will be lower level for the octahedral complexes, but in tetrahedral complexes, which is the lower energy, dx square minus y square and dz square will be that lower energy. In our last video only we have gone through. Okay, now we are going to see the distribution of electrons in the d orbital according to that nature of the ligand. Okay, Hans rule, what it has mentioned, electrons are filling in the orbitals in the singlet. Then if it is extra electrons are there, then it will go for doublet. The same way here we can go, but CFT, it is depends upon the nature of the ligand. So the nature of the ligand only we can go for that, whether it is a T2G or EG. So that means it is a lower energy level or higher energy level. So in that way we can identify low spin complexes or high spin complexes. So depends upon the nature of the ligand only, electrons filling taking place. Come on, let us go for that. As we mentioned here, dxy, dyz, dzx for T2G, it's a lower energy level. Whereas dx square minus y square and dz square, it's a higher energy level, we can say it's a EG. Now, for example here, D1, D2, D3. 3 electrons are there, means you can go and fill 1, 1, 1 here. Now, 4th electron comes, means that is depends upon the nature of the ligand. So that is 2 varieties we can mention. So D4 complexes, all the 4 electrons occupy in the lower level, that is T2G, or 4th electron will go to that higher level, that is EG. So that is depends upon what it is, nature of the ligand I just mentioned. So nature of the ligand, Suppose if it is lower energy, depends upon that. Two things we have to mention. Magnitude splitting of the crystal field splitting energy. So crystal field splitting energy, we can mention delta naught. So delta naught, it is crystal field splitting energy, and P for what it is, pairing energy. So pairing energy, P represents the energy required for electron in the single orbital, right? Okay, now nature of the ligand I just mentioned. No, so the nature of the ligand here, strong field and weak field. So how to identify delta naught and P, right? So whether it is a bigger, that means larger, or smaller, easily we can identify, depends upon the ligand. Yes, now crystal field splitting energy delta naught depends on the nature of the ligand attached to the free metal ion, right? So delta naught is larger, that means that is a strong field ligand. Delta naught, it is larger, means 100% this is a strong field ligand. So definitely electrons are filling in the lower level only, because it will adjust, so it will fill in the lower level only. So we can say it is a low spin complexes. So lesser number of unpaired electrons. Why? Because again it will go and fill, so that means the number of unpaired electrons will be lower. Whereas delta naught, it is small, ligands might be weak field ligand. So weak field ligand which is attached to the free metal ion. So that is what it is, Eg level. Definitely it will go higher level. So that means what it is, high spin complexes. So definitely, because here number of unpaired electrons, here unpaired electrons, number of unpaired electrons will be more in the, what it is, weak field ligand. So weak field ligands means definitely high spin complexes. Strong field ligands means definitely low spin complexes. In the low spin complexes, you can find very less number of unpaired electrons. Whereas here, high spin complexes, you can find more number of unpaired electrons. So easily you can identify high spin complexes, low spin complexes. High spin complexes means weak field ligand. Low spin complexes means strong field ligand. Strong field ligand, you are having lesser number of unpaired electron. Whereas high spin complexes, you will have more number of unpaired electrons. Hope you're clear with this, all these points. If you want, you can take that screenshot, or otherwise you can take the hint, because it will be very useful to easily to understand the points. Now, very clearly, you can make out weak field ligand and strong field ligand, how the electrons are filling in the d orbital. Okay, the first one, delta naught, it is lesser than P. You know what is it, P and delta naught? Delta naught, it is crystal field splitting energy. That will be lesser than the pairing of electrons in the orbital. So, P, it is represents pairing of electrons in the orbital, single electron. Okay, so that is actually weak field. So the fourth electron, where it will go? Suppose four electrons are there in one complex, means, so here dxy, dyz, dzx, and it is T2G level here. First electron and second electron, third electron. Fourth electron, it will go in that higher level, that is Eg level, it will go and occupy. That is what it has mentioned very clearly. So the fourth electron will enter into that Eg level. Now electronic configuration, how can you make out? T2G3 and EG1. Now here, high spin complexes. Why do we say high spin complexes? Because fourth electron will go to that higher level, that is EG level, it is a higher level. T2G, it's a lower level. I hope you're clear with this. Okay, now strong field ligand means delta naught will be larger than the P. So the symbol will be very clearly, you can make out. Now, suppose here four electrons are there, means here what happened here first, according to Hunt's rule, it will go and occupy single electron. Now, fourth electron will not go to the Eg level, it will go and pair the electrons, right? So that is what it has mentioned. Fourth electron will be pairing in the T2G level only. It will be there in the T2G only. Down it is. T2G level only. So T2G level, it will be low spin complexes. So what is the electronic configuration? T2G4. So that is what it has mentioned. Low spin complexes. So very clearly, weak field ligand means high spin complexes. Strong field ligand means low spin complexes. Weak field ligand represents delta naught is lesser than P. Strong field ligand means delta naught is greater than P. So easily you can make out. Suppose choose the correct answer. Multiple choice question comes means if they are asking such kind of question. I hope you are very clear. Easily you can write the correct answer. Okay, now strong field ligand delta naught will be high. Okay, why I am saying delta naught will be high? Here delta naught it is small in that weak field ligand. Delta naught will be high in that strong field ligand. That's what I just mentioned. Delta naught it is greater than P in that strong field ligand. Delta naught it is smaller than weak field ligand. Very clearly this mind map will help you to identify. Take that screenshot or otherwise you just take the hint. So definitely it will be helpful. Okay, now strong field ligand means delta naught will be higher and low spin complexes, and weak field ligand means delta naught it is low and it is actually high spin complexes. Hope you're clear. Okay, now we are going to compare some compounds with magnetic property. Okay, now one question. Where do we get more unpaired electrons? Whether it is a weak field ligand or strong field ligand. Answer these questions in the comment box. Hope you're clear with that point. Now we are going to see magnetic property. How to identify the magnetic property of these compounds. Okay, like comparatively. Now first one FeCN6 3 minus, FeH2O 6 times 3 plus. First and foremost, the same idea only we are bringing. What is it? Finding out the oxidation number of the central metal ion. Second thing, electrons filling. Now, how it is filling? Let us go and identify. Okay, now the first one. So, oxidation number of central metal ion. So, X plus 6 into minus 1 equal to minus 3. So, x minus 6 equal to minus 3. So, x equal to plus 3. Now, electronic configuration Fe, Z is equal to what it is? 26. So, how to write it? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, what? 6. 10, 10, 6, 26, right? Okay, now how many electrons we have to remove from the outermost orbital? Of course, 3 electrons. So, Fe3 plus, right? So, that means here 3d5, 4s0. See here, 3d5, 4s0, right? Now, we are going to fill the electrons in that T2G or EG. Let us go and find out. Okay, now first and foremost, what is this? Here, dxy, dyz, dzx, dx square minus y square, dz square. Okay, now here this is T to G level, this is EG level. Now, here you have to fill the electrons. Now, 5 electrons in that level. Now, CN is what it is? Weak field ligand or strong field ligand? Of course, it is a strong field ligand. Strong field ligand means what will happen, how the electrons are occupying. It will go on single, then it has to go for the double. Okay, now what is that delta naught? So delta naught, it is greater than P. Why it is greater than P? Because it's a strong field ligand. Now delta naught value will be very high. Hope you're clear with that. How to identify? Okay, now here, how many unpaired electrons are there? Here, only one unpaired electron. Definitely, unpaired electrons are there means it is having paramagnetic. What do we say it is a paramagnetic? Magnetic. Same ideas only. VBT like same idea only. Paramagnetic. Right? Okay. Now the next one. I hope you're clear with it. The next one, oxidation number. Oxidation number of central metal ion X plus H2O. What it is? 0. 6 into 0 equal to plus 3. Of course, X is equal to plus 3 oxidation state. Okay. Now the same way here. Fe3 plus. So definitely same number only. So we can write it directly 3D5. Now ligand series, how will you write it? The same. DXY, DYZ, DZX. So here dx square minus y square and dz square. Okay, now 3d5. It's a weak field or strong field. H2O belongs to weak field ligand, right? It's a weak field. So weak field ligand. So weak field ligand means how the pairing of electrons. Electrons will occupy that first what it is? T2G. Then after that EG. Right. So how many electrons? 1, 2, 3, 4 and 5. Why it is going higher level? Because it is a weak field ligand. It cannot pair up. So definitely it will go to that higher level. Now here this is a higher spin or lower spin? Definitely, this will be high spin complexes. High spin complex. Okay, now what is the electronic configuration? T2G3 and EG2. Right? T2G3, EG2 because it is 5 electrons in the d orbitals. Because it is a weak field ligand and how many unpaired electrons? Where there is more unpaired electrons, weak field ligand only. I asked that question. I hope you got an answer. Okay, now this is what it is. Of course, this is a paramagnetic only. Unpaired electrons, it's a paramagnetic. Paramagnetic. Right? Okay, now this is high spin complexes and the next one delta naught. Delta naught, it is lesser than P. So delta naught, it is lesser than P. So definitely what it is? Here low value. Delta naught, it is low value. Okay, here delta naught, it is high value. Delta naught, it's high value. Okay, now here I forgot one point. Here, high spin complexes. What about here? Because it is filled in lower level only. So it's a low spin complexes. Low spin complex. So easily you can identify. Hope you're clear with it. So what we are asking, magnetic property only. But we can identify high spin or low spin, weak ligand or strong ligand, and paramagnetic or diamagnetic. So 3 points we have made out. Okay, now the first and foremost, you have to see the complex compound. You have to find out oxidation number for that, and you have to remove the electrons from the outermost orbital. After that, you have to write the electronic configuration for the splitting level. Okay, as it is splitting level, strong field ligand means it can pair the electrons in the lower series. So definitely it is low spin complexes and the delta naught will be very high. Delta naught is greater than P. Remember that? And the same way here depends upon the ligand, nature of the ligand. I just mentioned no, the same idea. So this is weak field ligand. In that way, electrons will occupy in the singlet only. Why? Because it is a weak field ligand. So see the electronic configuration T2G3 and Eg2 out of 5 electrons. Right? Now this is what it is. High spin complexes. Why do we mention it's a high spin complexes? Because those electrons are going to the Eg level, right? Okay, now delta naught is lesser than P because it's a weak field ligand. Hope you're clear with it. Of course, this is going higher level, so that is high spin complexes. Delta naught, it is lesser than P. So this is the way we can go for some more examples. Now the next one, COF6 3 minus CONH3 6 times 3 plus. Okay, as we look at this compound only, we can come to know that is this F6, F, it is a weak field ligand, and this is strong field ligand, strong field ligand. Okay, now as we go for the oxidation number of the central metal ion, here X plus 6 into minus 1 equal to minus 3. So x minus 6 equal to minus 3. So x equal to plus 3 oxidation. Now electronic configuration we have to write it now. So CO it is 27, right? Right? Okay, 1s2, 2s2. Directly also you can put it. I am giving very clear idea. That is what 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7, 10, 10, yeah, 7, 27. Now remove the 3 electrons, so that means CO3 plus complex for that. So 3d6. Right? Here 4 is 0, no need to write because here like VBT we no need to keep that empty orbitals free, right? Okay, now 3D, how to fill the electrons? Now here dxy, dyz, dzx. The same way here dx square minus y square dz square. Okay, now the same way you have to fill them. This is what it is, weak field ligand. So that means it cannot pair up. So that means how many electrons it has to fill? 1, 2, 3 of T2G and 4, 5 and 6. 6 electrons, no? So that means here what it is, high spin or low spin complexes? Here high spin complex. Okay, now next one, what it is? What is the electronic configuration? T2G4 and EG2. And here delta naught, it is low or high? It's very low. So that means delta naught, it's lesser than P. And this is electromagnetic property, whether it is a magnetic property, paramagnetic or diamagnetic, this is unpaired electrons are there. So definitely what it is? Paramagnetic. Paramagnetic. Hope you're clear with this. All these points, high spin and electronic configuration and the level of delta naught and nature of the magnetic property. And the delta naught, it is very low. We got all that point. Now high spin or low spin means definitely you will come to know very clearly. Now the next one here, as we look at that CONH3 6 times, it's a strong field ligand. That directly we can go for that CO3 plus, right? So 3d6. So here dyz dzx dx square minus y square and dz square. Okay, now here 3d6. Now how to fill the electrons? It's a strong field ligand. So definitely 1, 2, 3 and pair up here. This is what it is, T2G and this is EG, right? Okay, so this is EG level only. Why? Because it's a strong field. Again, it will pair the electron. So T2G electronic configuration T2G 6. Right? Okay, now this is lower spin or higher spin? Lower spin complexes. Low spin complexes. Okay, now next one, what it is, paramagnetic or diamagnetic? This is a diamagnetic. Magnetic. See now, when COF6 means it's a paramagnetic, whereas CONH3 means it's a diamagnetic. Okay, now delta naught. Delta naught will be lower or higher? This is higher than P. Hope you're clear. So delta naught will be high. Hope you're clear with that, how to find out all these points. So here high spin complexes T2G4 and EG2 and delta naught, it is lesser than P because it's a weak field ligand, paramagnetic, whereas here T2G6 and it is a low spin complexes. Why? Because it is filling that lower level, T2G level only, and it's a diamagnetic and delta naught, it is greater than P. Delta naught, it is very high. Hope you're clear all these points. Okay, we'll go some more better examples. Now next one more example. MnH2O 6 times 3 plus MnCN6 3 minus. As we look at this only, we will come to know which is weak field and which is strong field. H2O 100% weak field ligand. Weak field ligand. And this one Cn now last before that, carbonyl compound it is last and Cn it is before that. So it's a strong field ligand. Strong field. Strong field ligand. Okay, now oxidation number you have to find out the next step. So X, central metal ion, no, X plus 0, right? 6 into 0 equal to plus 3. So naturally X equal to plus 3 only, oxidation state. Now the next one, electronic configuration, Mn, 25 atomic number. Okay, 1s2, directly also you can go, no problem. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Now you have to remove 3 electrons from the outermost orbital. Mn3 plus. I hope you got it. Now here how many electrons you have to remove? 3 electrons. So how many? 3d4. Now how to fill the electrons in that splitting way? 1, 2. Okay. Now here dxy, dyz, dzx. And here dx square minus y square dz square. Okay. Now 3d4. No. This is weak field. No. Weak field means can it pair up? Yes, it cannot pair up. 1, 2, 3 and 4. And here this is T2G and this is EG level, right? So that means this is low spin or high spin? Definitely it's a high spin complexes. First one, high spin complex. Okay, now the second one, a delta naught. Delta naught will be lower than P. So that means delta naught it is low. High spin complexes, but delta naught it is low. And next one, magnetic property. What it is? Magnetic property. Diamagnetic or paramagnetic? 100% paramagnetic. Okay, now one more point I would like to mention, total number of spin. How to find out this total number of spin? Number of unpaired electrons more means that is high spin complexes. So how many unpaired electrons are there? That number into half, because half spinning, one it is half circle only, no? So here how many total number of spin? Total number of spin equal to, so here how many? 4 into half. So total number of spin 2. Hope you're clear with this. All these points, whatever we wanted to mention, magnetic property and total number of spin. Okay, now the next one. Already we have gone through this. So this is what it is. Mn3 plus, right? So 3d4. Now here, how to fill that electrons? Just closing your eyes and you can do it very easy if you know the concept. dxy, dyz, dzx, dx square minus y square and dz square. Right? Okay, now you have to fill that. So this is strong field. You have to fill it in the lower level only. That is T2G. This is EG. Right? That means 1, 2, 3. This is 4, no? And 4, it will be pair in that lower level only. So what are the points to be identified? So the first one, here what it is? Low spin complexes. Low spin complexes. And the second point, what it is? Delta naught. Delta naught, it is greater than P. So that means delta naught, it is very high. Because what it is? Strong field. Okay, now next one. First, second, third. Magnetic property. Magnetic property, of course, this is paramagnetic only. Third point. Paramagnetic property only. And total number of spin. Total number of spin. How many unpaired electrons are there? Number of unpaired electrons are more. That is high spin. Number of unpaired electrons are less. That is low spin. Okay, in that way also you can identify, because to find out number of spin, even that question also they'll be asking. So total number of spin, how to identify? How many unpaired electrons are there? That is multiply with that half. Because spinning, it's half only, no, plus half and minus half. That is what. Okay, so here unpaired electrons, here 2 into half. That means 1. Hope you're clear with this. Both the thing. So here high spin complexes, low spin complexes, delta naught it is lesser than P, delta naught it is greater than P, paramagnetic it is common, and the next one, total number of spin. Hope you got an idea. In our next video, I would like to give all important questions, most important questions from the board and the CBSE board mainly. So please subscribe this channel and hit the bell icon so that you will get all the notification. Thanks for watching.